This question, which is based on the theorem called converse of midpoint theorem. The question says, E is the midpoint of the median AD of triangle ABC. So the figure is not given. That means we need to draw a triangle. Let's say I have drawn a triangle here. Right. I said any triangle and it's named as ABC. What we know further about this, that there is a median, right? And what's the name? AD is the median. So what is the median? It's a line joining the midpoint of a side with its opposite vertex. Right? That's called the median. So here the median, which is the midpoint of BC. Right. So we are given AD as the median. And there is, let's say E is the midpoint, right? So E is a point somewhere here, which is the midpoint. E being the midpoint. Let me write it here. That's better. E is given the midpoint. That means we know this is equal to this. Further, we also know these two are equal. Okay. Now, further, as I read the question, what it says that, yeah, AD, right? BE is produced to meet AC at F. So I have to produce BE. So what I'm going to do is to join B with E. This is E, and is produced to a point which is intersecting this at point F, right? So yeah, that's construction is done. Now what we have to prove here is to show that AF is 1/3 of AC. So we need to prove this is AF, right? This is AF. So the to prove part here is AF is equal to 1/3 of AC. Now, as I said in the beginning, that this is based on this theorem that is converse of a midpoint that says that it says that the line drawn through the midpoint of one side, right? So this is ABC. Line drawn through the midpoint of one side parallel to other side bisects the third side. That means here this is bisecting. So this is what the property. Now for doing this question, we have one construction. And what is the construction which I have written here? As you can see, I've written the construction, and the construction is through C, through the point C here, through the point, sorry, we'll be not through C, it's D. Through D, we will draw a line, as you can see, and it should be drawn parallel to, BF, right? So, which intersect AC at point G. That's what the part of the construction. So what I'm going to do here is that in the first go, I will prove AF is equal to FG, and in the next go, we'll be proving FG as equal to GC. This way, you can say that AF is 1/3 of AC. Now let's begin with the first. First, I'm going to consider this triangle. So the triangle I'm going to consider is this. So if this is not clear, then I'll shed it properly. So then the first go, I'll be taking this triangle. All right. So I'll write down the proof part here. That's the proof part. We'll write in triangle ADG. What we know that E is the midpoint, right? E is the midpoint of AD. That's given, right? That's given. And we have EF parallel to DG. And that's from construction, right? From construction. So therefore, by applying this theorem, you may write converse of midpoint theorem. We can say that F is the midpoint of AG. So it implies that here AF is equal to FG. And say I mark it as equation 1. So we did the first part here. And let's make space for the second part. Now, once again, we are going to consider, and this time, as I said, the triangle we will change here. This time we will be considering another triangle. So the triangle considered will be, let me show you. This time I'm going to consider this triangle. As you can figure out that we need to prove G, right? G as the midpoint. So let's say if I write the working part, so we'll say in triangle BCF, what we have in this triangle, you can see that D is the midpoint. D is the midpoint of BC. And this is how, because we know that this is AD is a median. And I told you in the beginning that median is what? Is a line divides the opposite side into two equal parts. That means BD is equal to DC. And this line is drawn, that is, this line is not visible. Yeah, this is parallel to this, right? These two lines are parallel by construction only. So we know that here DG is parallel to BF. So now, once again, by applying the converse of midpoint theorem, once again, by applying this theorem converse of midpoint, what you can say here that G is the midpoint, right? Therefore, G is the midpoint of what? CF. That implies from here we can say that if G is the midpoint of this CF, it means that FG is equal to GC. So FG is equal to GC. And I'll mark it equation 2. Now look into these two equations. This is equation 1 and this is equation 2. You can see that AF is equal to FG and FG is equal to GC. That means all three are equal. So we'll say that AF is equal to FG is equal to GC. Hence, we will say, therefore, AF is 1/3 of AC. And that's how we'll say that we have proved the final part here. Now let's move to the next question.